Well, good evening. Welcome to Lesson 9.6. Now, this lesson is titled Circles, and it's going to be everything that's in your pre-algebra book in this particular section about circles. But I'm going to try to squeeze a few other things in. So this should be everything that you will probably ever need to know about circles. And I'm going to try to get that all in the minimum amount of time. So put on your seatbelt, listen really carefully, tune in, and let's talk about circles. Let's start with the definition. A circle is defined as the set of all points that are equidistant from a single point. Now, that single point we call the center, okay? And it's basically a point right in the middle of the circle. Now, the distance out from that center point to any of the points that go around the circle is called the radius. You've seen this before. So this is just a little bit of review. There's another term. You may or may not have seen this, or well, you've probably seen it, but you probably don't necessarily remember it. Any line that cuts across a circle from one edge of the circle to the other is called a chord. Not to be confused with a chord in music where you play like multiple notes at once. This is a chord that is a mathematical term for a segment that goes from one side of the circle to the other. Now, the longest of all the chords, okay, is called the diameter. Let's make this a little bit longer. Okay, the diameter is a special chord for two reasons. One, it goes through the center of the circle, and because it does that, it's the longest chord that a circle can have. And another relationship is that a diameter is equal to twice the radius, because the radius is just from the center out to the edge of the circle. So if I think of a diameter as two radiuses, radii, going in opposite directions, that put them together, it makes a diameter. Okay. Now a couple more terms. The distance around the outside of a circle, okay, is just like any other figure. We could call it the perimeter, okay, but it's got a special name for circles. It's called the circumference, okay, and the circumference of a circle has to do with where pi comes from. We talked about this a little bit on Pi Day, but the circumference of a circle is equal to pi times the diameter. And a lot of times we use a capital D for diameter, and we use a small r to denote a radius. Okay, so radius is usually a small r, and a diameter is usually a capital D, and that just helps us remember that diameters are bigger than radii. Okay, another way to do the thing I just have here in yellow is where pi comes from, and that is pi is the ratio where you take the circumference, the distance around the outside of a circle, and you divide it by the diameter. In other words, you ask yourself, how many diameters would it take if there were little strings to wrap around the outside of any circle? And it turns out it's about 3.1415926, etc. Okay, so that's all the definitions of a circle. I think that's pretty much all I can think of. There is one more. We're going to talk about this in a little bit. But in here, these angles that are formed by radii and diameters, radiuses that have the vertex as the center of the circle, are called central angles. And we'll come back to that in just a second when we talk about circle graphs, which is a really good use for circles. Okay, let's go ahead to this circle right here. And that green line is not exactly perfect, but it's supposed to be the diameter. So let's assume it goes through the center of the circle. And so what I've shown here is a circle with a diameter equal to 8 centimeters. Okay, well, first of all, let's start with figuring out the radius. So if the diameter is 8 centimeters, the radius would be what? Okay, if you're thinking 4 centimeters, you just take half of it. That's exactly correct. The circumference, the circumference of this circle is equal to pi times the diameter. We usually put the number in front of pi. It's just a style thing. So we usually say 8 times pi, but that's going to be the circumference. By the way, the circumference is equal to pi times d. We just saw that formula. But also, we could substitute 2 times the radius for the diameter. And if I reorder this second equation, again, I usually put numbers in front of pi, so it's 2 pi r. Okay, both of those are a way to find the circumference. Okay, now all of that is in your lesson 9.6. I want to go one step further, and I want to talk about the area of a circle. And to do the area of a circle, we're going to take pi, and instead of multiplying by the diameter, we're going to multiply by the radius. Well, that might seem a little bit counterintuitive. So we multiplied the longer segment times pi to get the distance around. It seems like the area ought to be a bigger number. It's more stuff because it's everything inside. And it kind of is. So what we do is we multiply pi times the radius, but then we multiply by a second radius. So pi times r, which is often denoted as pi r to the second power, pi r squared. Okay. Now be really careful. One of the main problems or main simple mistakes that people make with circles is they confuse this r squared and they accidentally think that's doubling r, like you did right here when you were doing circumference. 2 times the radius gives you the diameter, and multiplying that times pi just gives you a length around the outside, the circumference. Okay. When you do area, you multiply the radius times itself. Okay, so let's go back to our example in green up here. So the area of the triangle above, we found that the radius was 4. So radius times radius is 4 times 4. It's not 8, it's 16 pi. And then also, when we do area, since we're measuring like how many little squares fit inside of something, the units are going to be different too. So it's going to be centimeters to the second power, or you can say, I'll rewrite the whole thing, you can write SQCM, with periods after both of them, square centimeters. So we can say it either way, centimeters squared or square centimeters, and that will be the area. Okay. Whereas the circumference for this one, let's go ahead and do 8 times pi, that should have been denoted in centimeters. That would be the unit for that. So that would be the circumference, okay, down here in yellow, okay, whoops, in yellow is the area. Okay, whoops. Well, all right, sorry about that. I lost the square. All right, so that's the basic definitions of a circle and the notation, and also how to find both circumference and area. All right, let's go ahead and try something different. A main use for circles is to do circle graphs. Okay, and it's one of the key types of circle graphs. So let's say I have a question on a test, and it's a hard question. And so a lot of people put a lot of different answers down. Okay, and so maybe this is question... I don't know, maybe it's question number 6 on a test, and these are the answers. Okay, and so you can look at this graph very quickly and realize that A was the most popular answer, that D was the least popular answer, D as in dog, and that B and C were kind of tied for kind of the middle of the road. Okay, now I could take something called a percent circle, and I can use the percent circle to measure how big a percentage each of these pieces are. Now, some of these I can kind of do on my own. Just eyeballing it, I can look at B and C and realize that those are 1/4 of the circle, which is going to be 25%. Okay, and I don't even really need to measure those. I can just kind of tell that these are right angles here in the middle, and that these are going to be quarters of the circle. Also, if I look at A and D together, I can notice that together they equal half the circle, and I would argue that A is about twice as big as D. So that would mean that D is about 1/3 of that piece, 1/3 of a half, so that would actually make it 1/6. All right, and so 1/6, if I write it as a decimal, is 0.16 repeating, or approximately 17%. Well, if the top D is 17% and I have 50% over here on the right side of the circle, then A must be about 33%. Okay, and if I actually take a transparent circle, percent circle, and put it down, what I would actually do is I'd put the 0 right here, and you always measure with a percent circle, you measure it clockwise, and I would actually use this line here, the green line here. I might have to extend it out, and I can actually measure to the nearest percent what the percentage is of A. Okay, we're going to do that. I'm going to give you one of these percent circles in class tomorrow, and we'll practice measuring circle graphs. All right, we're almost done, and it's only 8 minutes, so we're doing really well. All right, the final piece of the puzzle is how to make a circle graph. Okay, so suppose I have raw data. Suppose I get together with some buddies that I used to go to graduate school in. And we all get together down in Gatlinburg, and we talk about where people live from. And I want to draw a circle graph that shows where people are living now. So let's say there's a total of 10 of us. So the first thing you do is you take your data. There's 4 people in Kentucky now. There's 2 that are living in Georgia. 3 are living in Tennessee right now, and 1 person's living in North Carolina. So the first thing you're going to do is add up all your data. There's 10 people total. The next thing you're going to do is change it into a fraction, so we know what portion live in different places. So 4/10 of the people, or 40%. We can do it as a decimal, or I'm sorry, as a percent as well. Okay. 2/10, or 20%, live in Georgia. 3/10 live in Tennessee, which is 30%, And then finally, 1 out of 10, or 10%, live in North Carolina. So what I'm going to do is I'm going to come over here and I'm going to put the center point in, and I'm going to start with a radius. Okay? And 40%, that's going to be about that much. Okay? And these are the people that live in Kentucky. Notice I don't put 4, I don't put 4/10, and I don't put 40. The size of the piece of the pie tells me what portion live in Kentucky. Okay, and again, if I add the person that lives in North Carolina, the 10%, 40 and 10% gives me 50. That would be exactly half the circle. Okay, so we'll put the North Carolina person down here. I know it's out of order, but that'll actually help me a little bit. And then for Tennessee and Georgia, it's going to be a little bit closer. That's pretty good. Georgia's the smaller one. Okay, that's about 20%, and Tennessee would be the last 30%. And if I do this correct, and of course I'm kind of eyeballing it right now, but if I do this correctly using a percent circle, I can go ahead and I can construct a circle graph. Now, all graphs, whether they're circle graphs or line line plots or bar graphs, always need a title on top. So this would be, let's just write a quick description. This is where old grad school friends live. Okay, and if I want to be really specific, I can say, you know, the 10 people that got together in Gatlinburg for the weekend and what state they're currently residing in. If you want to make it longer than that, that's fine. But there needs to be something up here as a title that tells you what you're looking at in the circle graph. Okay, now I know I've talked kind of fast and I've just kind of whizzed through everything, but that is really everything that you need to know for circles. Okay, if you want to go back and rewatch a couple parts of this, that would be great. We'll be practicing this stuff in class, and if you have questions, I'll be glad to answer them in class. But that is everything that I can think of that you need to know about circles. So thanks for tuning in, thanks for watching, and we'll practice more in class tomorrow. Take care, everybody.